8.1 Vector and parametric equations of line in two dimension R2. Example 8. Consider the line R equals to 3, 4 plus t times 1 minus 3 where t belongs to set of real numbers. A. Find equation of a line perpendicular to the given line. B. Determine another point on the perpendicular line. Well, this is very interesting question, and we like to see now how to find another line perpendicular to the given line. In algebra you learned it was negative reciprocal, right? And here in vectors, let's see how we get that negative reciprocal. Now you learned in vectors that dot product is 0 for two vectors to be perpendicular, correct? So we'll use that principle here, correct? So let us use that principle and say let the direction vector m for the perpendicular line be AB, right? And now we know the direction vector of the line is 1 minus 3, correct? So, and the direction vector of the line, let me call this direction vector as m1, let me call this as line 1, is given to us as 1 minus 3, correct? Now for these two vectors to be perpendicular, their dot product should be 0. So a comma b dot 1 comma minus 3 should be equal to 0, correct? So if we do that, we get a minus 3b equals to 0. Now, so that is our dot product, and we have equated it to 0. Now a and b, we got two variables, one equation. So it is not really possible to get a good solution from it, right? Now what we do is, because the line is one parameter, so one dimension, and so we can find a's in terms of b's, right? So the simplest value which can make this 0 is if I say a equals to 3b, correct? Then it is 0, right? So let me write it like this first. Say a equals to 3b, right? So that is kind of a relation between a and b, a and b. As you can see in a triangle, if I draw a slope, right? So let's say this is my slope, right? So 3b is kind of ratio of a over b. Do you see that? So that makes sense. Ratio of a over b, right? That makes sense. Do you see that? It could be any number. So that is the concept which we use here. And we say, well, if b is 1, then a is 3. Do you see? So we say if b is 1, then a is 3, correct? Doesn't make sense. You could assume b to be 2 or even 1 over 3. If you assume b as 1 over 3, then a will be 1. So let's assume some value, but all will give us the same direction vector. That's the beauty. So that's why we say let b equals to 1. In that case, a equals to 3 times 1, so a equals to 3. Do you see that? And therefore we say, let me call this as a direction of a perpendicular line. So we say direction vector of perpendicular line for us is 3, 1. So that is how we find direction vector. We could have assumed b as 2. In that case it was 6, right? So let me do that part also and show you what happens if I take b as 2, right? So if I take b as 2, a becomes 6, right? So let me put a equals to 3 times 2, which is 6. And in that case, my direction vector will be 6 and 2, correct? Now I could have taken 3 common here, so I write 3 common. It's better to always factor it. If you get something like this, right? Take 2 common, Take 2 common, and then we get 3, 1, the same answer. So my advice here is that try to take simple values and don't put direction vectors in fractions, and let it be in the simplest form, correct, of the ratio, you can say. So for us, direction vector of 3, 1 is perfectly fine. Now once we get the direction vector, then we can write the equation of the line, correct? So let the equation of the line, in which form do we want to write? Let's say vector form, right? So the equation of the line perpendicular, let me call this perpendicular line. It could go through the same point, so we'll use the same point here, 3, 4 plus. So instead of t, I can write anything actually. So let me write s this time. And the direction is 3, 1. 3, 1, correct? Where s belongs to the set of real numbers. Do you get it? So that is how it is. And to find another point on this line, give different values to s, right? So let us say s is 1. If s equals to 1, then what do we get? We get a point which is 3 plus, let me write 3, 4 plus 3, 1, right? Which is equals to 6 and 5. So that is our next point at x equals to 1, right? So this is determine another point on the direction line, 6, 5, correct? So that is how it is. Now, as a check, right, we can just make a check whether our line is really perpendicular, right? So as a check, what we will do is, we will do a dot b, I mean, m1 dot m2. Let's do m1 dot m perpendicular, whatever we have. So we have 1 minus 3 dot 3, 1, and when we do this, 1 times 3 is 3, and minus 3 times 1 is minus 3, and you get 0. So since the dot product is 0, we are sure that the two lines are perpendicular, correct? Well, that is an additional thing just to give you an overview of different aspects of the same thing. I hope you enjoyed the process and you are an expert by now on vector and parametric equations of line. So it's almost time for us to move on to other types of equations like the scalar equation and the symmetric equation of line, and then we'll see the equation of line in R3, 3 dimensions. Okay, all the best.